Let's see how many examples we can get through in less than 7 minutes. So, right, cat? Meow. No, cat did not say nothing. I don't like cat. One time, I tie rock to cat, throw in lake. Cat die. Okay, it's a piecewise function. Oh, it's like we practiced this. It says let the f of x be this function and evaluate the limit as x approaches 2 of f of x. Well, here's the thing. We have to evaluate it from both sides, right? Because it's a double-sided limit. It's a two-sided limit. So, you know, if we're approaching from the left, limit as x approaches 2 from the left, that means we're plugging in values that are getting closer and closer to 2, but they're slightly smaller than 2. So we're going to use this stuff, because that's what the domain says. So we're going to say the limit of negative 2x plus 6. What is that? Well, we can do direct substitution. That makes it negative 4 plus 6 is 2. Be quiet. It's 2. And then the limit as x approaches 2 from the right, well, that means we have to use this function because the domain is stuff that's on the right side of 2, bigger or equal to. So we have to use that. And then a minus 1. And then what do we get? We get 4 minus 1. It's 3. Okay. So the limit is, and it does not exist. DNE does not exist. Because, you know, it doesn't agree from both sides. Alright, moving on. 2 minutes. Sheesh. We're not going to get through all these. The function f is defined by the formula. There you go. What is the value of c that will make the function continuous? Well, remember, to be continuous, the two-sided limit has to exist. They have to agree to each other. And also, when you evaluate the function at the point in question, the x value in question, it has to exist and it has to agree with the limits. So, the function f is defined by the formula, blah, 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 blah. What is the value of c that will make f continuous? So, all we have to do is find the limit, the two-sided limit, around 1. So, find the left-hand limit from the left, and then the right, and then set them equal, and then solve for c. So, let's see. The limit as x approaches 1 from the left, we will use this. It's a difference of cubes. X cubed minus 1 over x minus 1. X cubed minus 1, that's if we factor with the difference of cubes formula. That will be x, same, opposite, always positive. X squared plus x, always positive, plus 1. And it's going to be divided by x minus 1. If you plug in 1 right now, what you get 0 over 0. That's why I'm factoring. Remember, you go to try for the indeterminate form, and then we'll go to here. And then now we'd have plugged into 1. That would be 1 plus 1 is 2 plus 1 is 3. Okay, so the left-sided limit is 3. What about the right side, huh? The limit as x approaches 1 from the right side, well, that we have to use the other formula because it's from the right side. It's a little bit, we plugging in things a little bit bigger than 1. And then we get here, the limit, we just plug it in as this, it would be c times 1 minus 2. Okay, but what is c? I don't know. But for this limit to exist, both left and right, well, I guess, yeah, for the limit to exist, but for it to be continuous, you have to go from the left and the right, and they have to agree with each other. So, what I'm going to do is I'm going to set them equal to each other. And so, look at this. Plus 2, C is 5. C is 5. Okay? Yeah. I know it'll make f continuous because if c is 5, then it makes both of the left and the right limits agree. And if I plug in 1, I would be using this equation anyway. So if c was 5, then what would I get? I get 5 times 1 is 5 minus 2 is 3. Yeah, c is 5. Mambo number 5. Okay, moving on. The function f of x equal to that is not defined at x equals plus or minus 1. What value should be assigned to f of 1 to make f of x continuous at that point? Well, okay, we could have a graph. Say it looks like something like this. And there's a hole in my bucket. They're saying, how do we fill the hole? What for, this is x being 1, right? X being 1. I just made up this graph. It's not real, but they're saying, what should the y value be if this is going to be continuous? How can we fill in that hole? That's what it's saying. So really what I got to do is I just got to take the limit from both sides and see what they're going to. Okay? Okay. Maybe I just take the two-sided limit as x approaches 1. So limit as x approaches 1, what is that? 4x squared minus 4x. That's 4 minus 4 if I evaluate right now. And that's 1 minus 1. That's 0 over 0. So I get it's an indeterminate form. I got a factor. I can factor out the 4x. Right? I get x minus 1. And then on the bottom is the difference of squares. That's x plus 1 times x minus 1. Oh, it's beautiful. And then I get the limit as x approaches 1. I got to copy that down. This goes away. That goes away. And now I could plug in the 1, huh? 4 times 1 is 4. Over 1 plus 1 is 2. And that's 2, you know? That's 2. Okay, so the limit is 2. But there's a hole there. There's a hole. So what do I do? What do I do? Well, it's saying we'll just make a piecewise function. This is not, you don't have to write this, but like f of, or maybe we'll call it g. Nah, I'm not going to write it. We'll make f of 1 equal to 2, and that'll fill in the hole. So 2 there. All you're doing is making sure that there's no holes. Okay. Let's take a look at this. What do we got? We got, a 7-minute video. We'll be done. I'll make a part 2.